In part 2 of our videos on epsilon-delta proofs, we're going to take a look at a limit proof dealing with a linear function. So recall in our part 1 video, we worked on the scratch work necessary to prove that the limit as x approaches 2 of 4x subtract 1 was equal to 7. And what we came up with was a relationship between delta and epsilon that said delta should be less than or equal to epsilon over 4. This fact that we came up with in our scratch work is what we're going to use to construct our proof. And our proof is going to follow along with the formal definition of a limit. So what we need to do in our proof is start out with a claim that the absolute value of x minus 2 is in between 0 and delta, and then show that as a consequence of that, the absolute value of 4x minus 1 subtract 7 will be less than epsilon. So this is our goal. Now, one thing to keep in mind about these delta epsilon proofs is that they all mostly read the same way. They have the same basic structure. What changes is the work necessary to establish the relationship between the delta and the epsilon. So pay close attention to how these things start fitting together as we go through. So we're going to prove that the limit as x approaches 2 of 4x subtract 1 is equal to 7. The first thing I need to do is tell everybody about the relationship between epsilon and delta. So I say, let epsilon be greater than 0, and let delta be less than or equal to epsilon over 4. So notice I use the relationship that I established in my scratch work in the very first sentence of my proof. The next thing I need to do is make my starting claim. So now I'm going to say assume that 0 is less than the absolute value of x subtract 2 is less than delta. So now I've told everybody that the distance between x and the value x is approaching is within delta units. Now I have to focus on showing that if that's true, then 4x subtract 1 is within epsilon units of 7. So now I'm going to start working on this inequality. And basically I'm going to go backwards through my scratch work. So now I say since delta is less than or equal to epsilon over 4, the absolute value of x minus 2 is less than epsilon over 4 as well. Then 4 times the absolute value of x minus 2 is less than epsilon. So now I've got epsilon on one side of my inequality. Now keep in mind what I'm trying to get to. I want to say something about 4x subtract 1 minus 7. So next I'm going to pull the 4 into the interior of my absolute value. So 4 times the absolute value of x minus 2 is equal to the absolute value of 4x subtract 8. And negative 8 is equal to negative 1 minus 7. So the absolute value of 4x subtract 1 subtract 7 must be less than epsilon. So this is what I really wanted to get to. And notice all I did was step backwards through my scratch work. Now that I've established that, I write my conclusion. So I say because the absolute value of 4x minus 1 minus 7 is less than epsilon, whenever 0 is less than the absolute value of x minus 2 is less than delta, the limit as x approaches 2 of 4x minus 1 is equal to 7. And I have now finished my proof. So I always step through the same series of stages. I start out by telling everybody that epsilon is a positive number and its relationship with delta. Then I assume that x and the value it approaches are within delta units of each other. Then I take my inequality about x subtract a, and I work backwards through my scratch work to establish the inequality between f of x and L. Once I've established that inequality, then I write my conclusion, and I'm finished. So now let's take a look at another limit. And on this one, I'm going to repeat my scratch work and then write my proof next to it so that you can see how the two things are linking up with each other. So this says, prove the limit fact that the limit as x approaches negative 4 of 5x plus 12 is equal to negative 8. So I'm going to come over here and I'm going to do my scratch work on the left. And since this is my scratch work, I want to make sure that I clearly label it as my scratch work. So I say, well, I'm going to take the absolute value of 5x plus 12, subtract negative 8, and that needs to be less than epsilon. Combine my like terms, factor out my 5, divide, and now I know that delta needs to be less than or equal to epsilon over 5. So that's all there is to my scratch work, figuring out how delta and epsilon relate to each other. Now that I've got my scratch work done, I'm going to write my proof. So I start out the same way I always do. Let epsilon be greater than 0, and let delta be less than or equal to epsilon over 5. I assume that the absolute value of x subtract negative 4 is less than delta. Really, I should get a 0 in there, so let's fix that. Back up just a little bit. We're going to assume that 0 is less than the absolute value of x subtract negative 4 is less than delta. Now, my job is to turn that statement about the absolute value of x subtract negative 4 into a statement about the absolute value of 5x plus 12 subtract negative 8. So this is where I'm going to start working backwards through my scratch work. So since delta is less than or equal to epsilon over 5, the absolute value of x subtract negative 4 is less than epsilon over 5. Now I'm going to isolate the epsilon on one side of the inequality. So next, 5 times the absolute value of x subtract negative 4 is less than epsilon, and the absolute value of 5x subtract negative 20 is less than epsilon. So I'm almost there. I just need to break this negative 20 up a little bit. So I can say, since 20 is equal to 12 subtract negative 8, the absolute value of 5x subtract negative 20 is equal to the absolute value of 5x plus 12 subtract negative 8. So we now have that the absolute value of 5x plus 12 subtract negative 8 is less than epsilon. Now we have one more piece in our proof. We need to write our conclusion. So we say, because the absolute value of 5x plus 12 subtract negative 8 is less than epsilon whenever, now we need to move our paper a little bit. So because the absolute value of 5x plus 12 subtract negative 8 is less than epsilon, whenever the absolute value of x subtract negative 4 is less than delta, the limit as x approaches negative 4 of 5x plus 12 is equal to negative 8. And we've finished our proof. Here's a problem for you to try. Prove that the limit as x approaches 6 of 2x subtract 4 is equal to 8. First do your scratch work, and then once you've established the relationship between delta and epsilon, see if you can write your proof. So pause the video, work through the problem, and then restart to check your work. Okay, so let's see how you did. Let's start out with the scratch work for the problem. So in my scratch work, I'm going to start out with the absolute value of 2x subtract 4 subtract 8 is less than epsilon. I'm going to go ahead and combine like terms and write that as absolute value of 2x minus 12 is less than epsilon, and factor out the 2. So 2 times the absolute value of x minus 6 is less than epsilon, and then the absolute value of x minus 6 is less than epsilon over 2. So I now have established that delta needs to be less than or equal to epsilon over 2. And that concludes my scratch work. Now let's actually write a proof of this limit fact. So here's my proof. I'm going to let epsilon be greater than 0 and delta be less than or equal to epsilon over 2. I assume that 0 is less than the absolute value of x minus 6 is less than delta. Then, the absolute value of x minus 6 is less than epsilon over 2, and 2 times the absolute value of x minus 6 is less than epsilon. So next, the absolute value of 2x minus 12 is less than epsilon. And since minus 12 is equal to minus 4 minus 8, the absolute value of 2x subtract 4 subtract 8 is less than epsilon. So I have now established the inequality that I need, and I can write my conclusion. Because the absolute value of 2x subtract 4 subtract 8 is less than epsilon whenever 0 is less than the absolute value of x minus 6 is less than delta, the limit as x approaches 6 of 2x minus 4 is equal to 8. And we have completed our proof.